All right, so I'm looking at number 57 now, and 57, I'll be doing 57 and 59, and these problems, I chose to do them because they're a little bit different from the others in that I'm working in the reverse order. And I know a lot of times when you can deconstruct an idea, it helps it to kind of become more solidified in your mind. So, so I'm looking at it, and it's asking us to write these formulas or write these series of terms in sigma notation. And it's also telling us that the lower bound is given. So the lower bound here is n1. So as I'm looking at writing it in sigma notation, my lower bound I know is n1. So the next thing I want to find now is my upper term, and then I also want to find my formula that goes here. So my upper term, this one's not going to be too difficult because all I have to do is look at the number of terms that I have, because it gives me the list. It gives me the list of numbers here. So I know that this is my A1, my A2, my A3, my third term, and 4, 5, 6, 7, 8, and it goes all the way to 8 terms. So then now I know my upper bound, and my upper bound is 8. So then all I have now is to find my actual formula. Now, finding the actual formula can be a little bit tricky because I need to look at my numbers carefully and see if there's any kind of pattern that it gives me. And there is a pattern. I'm adding 1 to every term here. So since I'm adding 1, well, one of the things that I want to do is I want to see the difference. I want to see the difference in each number, because let's see here. So I know that my first one, my n1, is 1, right? So let's see here. How could I write this? So some number plus, and in this case my number is 1, right? Plus some other number is going to give me my a1, which is negative 2. All right. So my 1, I have to do, I'm doing some operation. It can be either multiplication, division, it can be anything that I'm doing to that 1. So this 1 here, I'm paying close attention to, and I'm doing something to that 1. I'm doing something to it to give me negative 2. And you know, this pattern continues on, because so my next term would be 2, right? I will be doing something to this term to end up getting negative 1. And then the same thing with my third term, with n equaling 1, equaling 2, and equaling 3, I will do something to that term to get 0. So this number, whatever I'm doing to this, whatever I'm doing to my n, whatever I'm doing to that n, it's going to be the same thing each time. And I need to figure out a number that did it. So you know, this number down here is actually going to be a big clue, because what can I do to 3 to get 0 but add it to negative 3, right? So let's see if that works with the others. So 1 plus negative 3 is negative 2. That checks out. 1 plus negative 3 is, I'm sorry, 2 plus negative 3 is negative 1. That checks out too. All three of them check out. So that must mean that whatever I'm doing to n, I must be adding negative 3 to get my terms here that are following, my a6, a7, all the way a8. So that means I am subtracting 3 from my term, or from my n, my lower bound. So whatever my lower bound is my starting point, and from that point on I'm adding, you know, my n changes from 1 to 2 to 3 and so on, and that will this number here, or this formula basically tells me what the pattern is, and how I get from my one term to my second and my third, fourth term, and so on and so forth. Okay, so let's look at number 59. Let's look at 59 and see what 59 is asking us to do. So 59, we're given the numbers 8 plus 27 plus 64, and then it's telling us that it ends at 1000, and it's giving us the lower bound at negative, or at n equals 2. It's kind of tricky. So my lower bound is 2, and I don't know what my upper bound is, because I have this nebulous dot, and I don't know how many numbers are in between there. So just like the last one, I need to find my upper bound and I need to find my formula there. And unlike the last one, it doesn't give me a finite list of numbers so I can find my upper bound. So I'm going to go ahead and divert my attention to the pattern of the numbers to see uh, if that'll help me find the formula to this, and then maybe I can then find my upper bound. So as I look at 8, 27, and 64, and 1,000, I'm almost tempted to say that these are perfect squares, but not quite. Now, 1,064 might be, but 8 and 27 aren't. So squaring them or square rooting them will not work. But I have a suspicion that they're going to be in the family of manipulating them in an exponent form. Because if I go back to my previous one, as I was looking at the pattern from here to here, an addition pattern came up. But the problem was, adding what? What was I adding necessarily? So in this case, I don't have necessarily an addition problem, but I have some exponent. So my in term, I don't know. Am I going to square it? Oh, well, I'm not going to square it because I already know that. What about cubing it? Let's see. Now recall that I start off. I'm doing it right here. Recall that I start off at n2. So that means this is my second term. This is my a2, and this is my a3. So that means my n was 2. Now if I square it, it equals 4. So it doesn't work because here it's 8. But if I cube it, it equals 8. Okay, so that works. Well, what about my third term? So if n equals 3 and I cube that, what does that equal? 27. It looks like I'm onto something here. Well, what about number 4? What if I cube 4? That's 64. And it looks like this pattern is going to hold. So I've just discovered my pattern, and it is, I'll do it in red, or I'll do it in blue. It is my n term is going to be cubed. That's my formula. So now that I have my formula, can I use that to find out what my upper bound is? And so as I look at 1,000, if I cube root 1,000, okay, if I cube root 1,000, I know that that's going to be 10, because 10 times 10 is 100, and times 10 is 1,000. So that means if this is 10 cubed, that means n equals 10 in this case, so my upper bound is 10. So I go from my lower bound 2 to my upper bound of 10. And this is my formula, all of this right here. And that's it. I've just successfully written my series of numbers with my lower bound in sigma form, okay, or sigma notation, sorry. So, take a look at these two problems and really analyze how I worked them out. And, so all we're doing is we're deconstructing the idea of sigma notation and working it backwards. And I think you'll find that it works either way. So work out the evens on your own, and then we can talk about them together in class.